Hello, welcome to Cracking the Cryptic. Thank you for being with us. We take great pleasure in you daring to spend some of your time watching some of our Sudoku solves, or even just clicking on the links to try the puzzles. Now, today's puzzle is by Doomed Yacht, who has not appeared on the channel for some time and says quite rightly in their email that they have a bit of a reputation for providing difficult channels on the puzzle, and maybe this will help deal with it. Well, I don't know if that last bit is right. We will see when we try it. But this one's called abatement. I'll go through the rules in a moment. The diagonals may not be what you're expecting. I'll say that because I read the rules once already. Okay, firstly, don't forget that on Patreon we have the fantastic oil and water puzzle hunt by Blobs. It's 10 Sudokus, in fact it's 12 Sudokus, you only have to solve 10 of them to be in contention for a prize. The prize this month is the chance to do a collaboration video with Simon. It has been turned down once, but has otherwise been accepted and turned in some very good videos. So that is coming up in the future. Of course, there's also the connections videos on Patreon and my solve of the Times Monthly Club special. There are some tough Simon solves from the past there as well that haven't appeared on the main channel. What has appeared on the main channel is, of course, our collaboration with Matt Parker, as well as Simon's with Dominic, the last competition winner. And the blueprints videos. If you go to the live section, you will see not only any future planned streams, but the past, our attempts in this changeable house to try and set up the blueprints to make it work. Anyway, that's been great fun. We've also, of course, got all of our apps. They're on a link under the video, and they do feature Line Sudoku. We don't have a Quadruples app yet, but they do also feature Fog of War, which is great fun. SVEN'S Sudoku Pad's link there as well, and our merch, including the Secret Squared t-shirt. And otherwise, have a look at the first link under the puzzle, which will lead you to Abatement by Doomed Yacht. And I'm going to go through the rules. Normal Sudoku rules apply. 1 to 9 will go in every row, every column, and every 3 by 3 box. Now, each of the main diagonals may only contain 3 distinct digits. This is the anti-diagonal rule. You normally see these as blue sometimes marked, and they contain the digits 1 to 9. But here there are just 3 different digits and they repeat on the diagonal. And the same is true for this diagonal, obviously not the same 3 digits. Now, digits in a quadruple circle must be placed at least once in the 4 cells touching that circle. So 1, 2, 6 and 7 must appear around here. At least 1, 3 and at least 1, 6 around here. And the cell with the grey circle must contain an odd digit. So not complex rules. We don't often see the anti-diagonal rule. I rather like it. Let's give the puzzle a try, see how we go. Let's get cracking. You can try and judge from the video length how hard I found it. Now, something that often helps with quadruple puzzles is finding X-wings. I mean, we see a big X in the puzzle. That's not what I'm talking about. I'm talking about identifying places like here. There's a 1 and a 2 in that group of cells, and there's another 1 and a 2 in that group. Now that means that none of these cells can contain a 1 or a 2. I'm just trying to work out if that's any use in the context of this puzzle. That's more use when you can confine a 1 or a 2 somewhere. And it makes a difference to how you see a puzzle. I don't know. I'm not sure that it does really help much in this one. Yes, you can keep 1 and 2. You know that they're not, well, I mean, we already know they're not there because this is a 4, 5, 7, 9 quad. So all those 4 digits have to appear in those cells. In fact, maybe it's what's missing out of these. So in this group of cells, we're told where both 1s and 2s are. We're told where both 3s are. And both 6s and 7s. So there's in the remaining cells, which are 2 there, 2 of these, and 1 of these. That's 5 cells. What do we have? We have 2 8s, because 8 hasn't appeared at all, a single 4, a single 5, and a single 9. I don't know, it feels like that's interesting, but I don't quite know how to use it, if I'm honest. Every actual indication in this puzzle feels like it's almost telling me something and not quite doing it. 1, 2, 6, 7. Let's try fully pencil marking these 4 quads on the intersections. What does it mean? So again, these 2, yeah, I mean, there are similar sets of digits being repeated or not repeated. I don't know. I don't understand what this is doing. If there's a 4 there, then 4 and 4 would be in those cells. And there would have to be 1 4 in one of those. I don't see that that really helps me. Oh, goodness. There's obviously something interesting as well about... Right. There's a 6 in one of those and a 6 in one of those. So does that mean that the 6 in column 7 has to be in one of those? No, I don't know. I don't know how much to use the anti-diagonal rule and how... These 4 cells obviously all have to be different. They're in the same box. Oh, am I right? No, I'm not. I was going to go, do those 2 have to be... Oh, that's interesting though. These are 2 different digits, and these are 2 different digits, but there are only 3 digits on this diagonal. So these 2 different digits can't be totally different from these 2 different digits, i.e. there must be an overlap. That overlap must be the number 9. So 9 is definitely on this diagonal, and therefore it doesn't appear in these cells. It must be one of these 2, along with either 4, 5 or 7. It must be in one of these 2, along with either 1, 3 or 8, and it's not in those cells. So there is always a 9 in that group and that group. In fact, I'm going to pencil mark those. When I put marks in the corner of a cell, it indicates as far as possible, it indicates the places left in a box where that digit can appear. So 9 is one of the ones there. Now, we've got to have the same here, but it's not as easy, because either 2 or 6 could fill that role on this diagonal of 9 on the other diagonal, which is to say, this indeed could be a 2-6 pair, and this could be a 2-6 pair, but it doesn't have to be. 6 might not even appear on this diagonal at all, or if it did, it might not appear on the in those 2 cells. Bother. I mean, there's more overlap than... This was the right diagonal to start with, to get this one deduction, the only thing I've actually done in the puzzle about 9s. Now, 9 definitely appears in those 2 cells, and it definitely appears in those 2. What does that tell me? Not a lot. There is also a 9 in this group, and that means... That doesn't mean a vast amount. I'm sorry to the author of the puzzle. I don't really understand how to interpret it. That may be exactly what they want. I do feel there's something to be grasped here. When you get it, you can probably make quite a lot of progress in the puzzle. But until then, not so much. Okay, come on, Mark. Think it through. 9. There's a 9 here. So these cells can't contain 9, and none of these can. 2, 3, 6, 7, 8 are the missing digits that aren't mentioned in their quadruples. So go in either, well, 2 of them there, 2 of them in that group, and 1 here. 2, 3, 6, 7, 8. I do not know how to use that information. I don't think it's very usable at all. Goodness gracious, I don't know what to do here. Just keep thinking about it. We've got a 1-2 pair there. We've got a 1-2 pair here. These could include 4, 5 or 7, 1, 3 or 8. 1 each. So well no, but that's on this diagonal. Well, there's no 2 or 6 on this diagonal. I haven't actually explicitly referenced that, but it's definitely the case. And also, well, we already knew that 2 couldn't be in that group because it features twice in columns 1 and 2. Now we know that 2 can't be there or in any of those. Okay, keeping focused on where 2 can't be in the central box. Right. I'm going to yellow some cells where 2 can't be. It's not on that diagonal. It's not in this cell because there's a 1-2 X-wing going on there. It's not in this cell. No, hang on. This cell because there's a 2 X-wing going on here and here. Now. Interesting, maybe. I don't know. Is this interesting? 2 can't be in any of those in any of those cells. So it's in one of these 4. I mean, it's a favourite to be on this line. I'm not sure. I don't see that it's proven. I mean, it's also true that 6 can't be there and 6 can't be there. Oh, is there any digit that appears in... Ah, that would be really useful in all sorts of X-wings. So the ones that are in X-wings here are 1, 4, 5 and 9. Remember those digits for me. The ones that are in X-wings here are 1, 5, 7 and 8. 1, 4, 5, 9, 1, 5, 7 and 8. So 1 and 5 have appeared in both those. 1 again appears here, doubled up. And all of that means that 1 can't be in any of those cells, I think. But 1 doesn't appear twice in circles here, although 5 does this time. So, unfortunately, I'm left believing that 1 could still be in this cell, let alone in any of these on the diagonal, on the diagonals in box 5. It was a different approach though, and it's quite interesting. I don't know. The fact that we know 9 is in one of these, is that usable? Not really. The only 9 we've got outside the diagonals, quadruples, is in that pairing. If I knew that wasn't 9, one of these would be 9, and then I would know 9 couldn't be in quite a lot of cells in rows 8 and 9, but it's not enough. Or do I think about 4s, for instance? They appear twice there, so where's the 4 in this row? It's certainly not mentioned in any of the circles between rows 6 and 7. So it's either a hidden digit in this quadruple, one of this pair, or the only hidden digit in that quadruple, the 4 in row 7. And there's another 4 in row 6 doing much the same. Fours feel quite interesting. I don't know. I mean, every digit seems to have fairly equal weight in this puzzle. Fives can't be there or there. Now, 5s were one of the digits I was seeing a lot of. 5s can't be there or there. And 5s can't be there or there. So again, I'm left with 4 places for 5 in this row, in this box. Which are those 4? I don't quite understand how I'm meant to know anything about this. Okay, I didn't think enough about which 3 digits are on this diagonal. Could 9 still be one of them? And say 2 and 6? I mean, it would be fairly easy to do, I would have thought. The fact that 9 is in one of those cells and one of those. Only one digit out of 4, 5, 7 and one out of 1, 3, 8 can appear on this diagonal. So this digit, I don't know. With these pairs, the central digit might not even be in these. Okay, the only way the central digit is not in these quadruples is if these pairs are 2, 6 pairs. I'm suddenly starting to wonder about the Fistomephel ring. Is that interesting here? The theorem that these 16 digits are the same as these 16. I don't know. I don't know how to use it if it is. It probably is interesting. Goodness me, I really don't see how we're meant to be making progress here. Sorry, I'm just sitting, staring at this grid for minute after minute and not understanding anything about how it works. Oh, here's something. Finally. 6 is in one of those and one of those, also one of those and one of those. That means 6. Oh, no, it's not something, finally. I was going to say 6 can't be in any of those cells and must be in one of these 3, but it can. It's obviously pencil marked there. It could be there. It can't be in any of these cells. That was on the verge of being interesting. I suspect that there isn't a digit that I can actually do that successfully with, because they're probably all symmetrically disposed. Symmetrically disposed. 4 can't be there. 1, 4, 5, 9, nor can 9. Wow, I don't get this at all. Is that little odd circle, is that actually doing something funky? Can't be. Is it to do with the fact that 2 appears in both of those? So if you were to put it there, you would have to put it in one of those 2. Then it would be in one of, well, it would be very specifically there. So if 2 was there, 2 would have to be in one of these. The 2 around this diagonal would end up being there. That's quite interesting. Then you'd have a 2 in one of these positions. You'd also have a 2 in column 3 in one of those positions specifically. Again, that feels quite interesting. I haven't worked out which of these would be a 2. I feel like maybe I should know. But I don't. Oh, well, no, this is impossible. Right. 2 cannot be there. Okay, I've got something. 19 minutes in. I've got the least little thing. Right, 2 cannot be there because 2 would have to be in one of these cells due to the 2, 7 diagonal. And then 2 around this quadruple would have to be there, but that implies that 2 is in this trio because these numbers must repeat on this diagonal. And that's impossible if we're saying 2's in one of those cells. So 2 is not in one of those, and 2 therefore is in one of these 2 and not there. Now, I must be able to replicate this finding around all over the place. So what I need to do is find cell digits that repeat in places like that, but then are also in a touching quadrant here. Maybe this isn't going to happen again. We've got 4 in both of those groups. It's not going to happen again, is it? That's so annoying. Oh, maybe it works. No, it doesn't even work the other way around. If I'd said 2 was there. Oh my goodness, it doesn't work the other way around. Is it literally only that finding for 2? No, look, 6. 6 can't be there because it would be there, it would have to go there, and then it would fail to get on the northeast part of that diagonal. So 6 is confined into one of those 2. So that seems to be the equivalent posting. 8 is in those 2, but not anywhere in those cells. 4 is in those 2, but not anywhere in these cells. So that doesn't replicate. Bother. So all I've got out of that is this 2 and that's 6. Now I suppose that means 2 and 6 are not digits on this diagonal, but we knew that already. I knew that already because we know that this has a 9 and 1 digit out of 457 and 1 digit out of 138. So where's 2 in this box? It can't be on that diagonal. It can't be in these cells because there's a pair of 2's looking. So 2 is in one of those 4 in this box. Is that any use? I don't think so. I'm telling you, Doomadiot, you're not doing your reputation of setting easier puzzles a boost. This is very hard to me. I'm sure if you can think of the issue, it's much more doable, but I mean, isn't that fatuously obvious? Okay, there's a 7 in one of those 4 and a 7 in one of those. Now in one case, that's going to keep 7 off the diagonal because either that pair or that pair is a 7, includes a 7. So then 7 can't be in one of those strings. But which one and why does it matter and how can I tell? Don't know. Okay, let's imagine one of these is a 6. Then there's also a 6 in one of those cells. And we already know there's a 6 in one of those two and a 6 in one of those two. Have we got any other information? We now know 6 is not on the negative diagonal. No, I don't see anything obvious. Okay, how about if this is 1, 7 and 6 is here, then 6 is here. If that's 1, 7. This is a, if that's, well, one of these we now know is a 2. I don't know if this is doing anything at all. I don't even know that one of those is a 2, although I know that one of these is a 2 and one of these is a 2. It could still be a pair there. And then neither of these would have to be a 2, and there wouldn't necessarily be a 2 on this line. Then there would be a 6 on this line. There is at least either a 2 or a 6 on this line. It's the smallest actual information. Why can't I extend what I learnt at all about 2s and 6s? I just can't. Right, if 3 was there, 3 couldn't be on this diagonal anywhere. If 3 was there, 3 would be in there. So in that case, 3 couldn't be on this diagonal. Oh, okay, well that's telling me that 3 is not in the middle. The middle cell is reserved for something that can be on both diagonals. And 3 can't be, because it must miss one diagonal because of this pairing of 3s. Right, 7 is the same. 7 can't be in the central cell because it's on both those sets. 5, 3, 7, 5, and 1. None of those can be in the middle. So the only odd digit it can be is 9, and it could be any of the even digits as far as I can see at the moment, but let's have a think about that. Because I think 2, 4, 6 and 8 all have similar sort of appearances along the intersections. 4 is in both of those groups. And what does that mean? That means none of these digits are a 4. And why does that mean 4's not in the middle, I wonder? If 4 was in the middle, it would be in one of those two, in one of those two, in one of those three, and in one of those two. It would have to be there and there. Oh, well, okay, 4 can't be in the middle, because then it would have to be there, and there's nowhere for it in column 7. Because if that's 4, that can't be 4. Right, I bet I can eliminate all of these even digits in the same way. 2 can't be in the middle, because those couldn't be 2, and none of those could be 2. Sorry, if 2 was there, you'd have to have a 2 in one of those cells. The very fact is 2 has been eliminated from that diagonal and 6 has been eliminated from that diagonal, so this can't be 2 or 6. Right, and now I'm just going to establish that it can't be 8, I hope, and we're going to write a 9 in if that's right. If it was 8, 8 would be in that pair and that pair and that pair, and couldn't be there. Yes, it can't be 8. It's a 9. Right. Right. So those two can't be 9. So this is the 9 that goes around this 1, 3, 8, 9 now. If I've eliminated it fairly from those cells. I don't know how I did that earlier. I mean, there must have been a very good reason. I can see now why I've eliminated it from those. How did I know? Because, yeah, we worked out that 9 was the repeat digit on this diagonal. And therefore, within these cells, you can't have 2 digits that won't be there, or you'd have 4 digits on the diagonal. It was right. That's 9, that's 9. Okay, I've done something. And I probably shouldn't have taken me that long, but I found that a very complex break-in of any kind. Now, then what? We're not much further forward, but we've got a 9 in the middle. That means 9's in one of those 2 cells and one of those 2, because it must reappear on that diagonal twice. Now it has to be in one of those 2 cells, because there's this 1, 4, 9 here. That's the only other one there was outside the main drag. So in row 4, 9 is either in one of those 2 or one of those 2. In row 6, one of those 2 or one of those 2. I don't quite know how to determine one way or the other. This circle is not 9 now. I had earlier thought it was going to be 9. But then at various other times I'd wondered if the middle cell would be 9, and that turned out to be true at least. So if 9 was here, it would be filling up this 5, 6, 7 quadruple as 5, 6, 7, 9. And then it would be here filling up this 1, 2, 3, 9. And then what would we know? I don't know. If this was 5, that would be the 5 around this 4, 5, 7, 9. You'd also have a 5 in one of those cells. That would have to be 5. Oh, there'd have to be a 5 in one of those 2. And therefore, this doesn't work. Right. Where did that chain start? This one has become impossible. Right, let me just figure that one out again. I don't even know where I began that. I think I said, yes, if this is 5, that has to be a 5. The 5 in the central box, I then, oh no, there's definitely a 5 in one of those two cells. So the 5 in row 5 then has to be there. But this 4-5 needs a 5 on, and now you can't get the one on up here. Okay, so that's not a 5. I mean, it's not really a generic deduction, but it is true. So let's think again. If that's a 5, then one of these two is a 5, one of these two is a 5, now one of these two is a 5. Keep going. We can't have a 5 on the negative diagonal, so that's a 5. That's a 5. One of those two is a 5, and this time it works. That's really annoying. Although it's not on the positive diagonal either, so one of those two is a 5. It's not on the negative diagonal either. So one of those two is a 5. Yeah, that does work, so I can't rule that out from being a 5. Oh, that's really weird. How can I extend the lesson of this not being a 5? Was they equivalent to that? This being a 1? If that was a 1, you have a 1 in one of those cells. You have a 1 here, then you have a 1 here, then you have a 1 here, and then you can't have a 1 here. So yes, that is the equivalent. That can't be a 1. Now what? One of these has to be a 1, I wonder? If that was a 1, what would that mean? It would mean one of these two was a 1. One of those two, one of those two, one of these. Again, the opposite always seems to work quite well, so it wasn't a big elimination there. Ah, goodness, sorry. This is very hard to map a way through. I just don't see how it's obvious how we find anything out here. And it's been very odd to me that you could eliminate individual digits from certain places. I can't see the patterns. I can't see the patterns. If that was a 7, then 7's not on the positive diagonal, so that couldn't be a 7. So 7 would have to be here. Yeah, that's quite interesting. Then there's a 7 in one of those cells. It can't be there because there's an X-wing on 7's in rows 6 and 7. One of these two has to be a 7. I want to keep going because this is an extrapolatable choice. 7 is not on the positive diagonal, but it is on the negative diagonal, so it has to be in one of those two. Right, so if this is a 7, this is it. This is what I have to use, is the negative diagonals here. So, sorry, the positive information about diagonals. So 7 would be in all of those places in boxes 1, 2, 5, 9. Now, it would have to be around certain marked places as well. And that's leaving it to be there. and in one of those two. Now, has anything failed about that? Not obviously. Not obviously. Oh, that's annoying. Okay, let's try it with, I mean, it's going to probably be the same result with another digit chosen from these cells that might appear there. So if that's a 1, then 1 is not on this diagonal, so it can't be there. So that would have to be a 1. It'd be a 1 here, a 1 here, a 1 here. A 1 there. A 1 there. A 1 on that diagonal. Ah, this would have failed, interestingly, because I'm trying to get a 1 up there. Right, if that was a 1, 1's not on the positive diagonal, so that's the 1 around the 1, 2, 6, 7. And that pushes 1 into one of those cells, but it's also meant to be pushing 1 into one of those. So that's not a 1. Right, let's try this again with a 7, just in case that works in some alternate way that I wasn't picking up before. If that's a 7, 7's not on this diagonal, so it can't be there. So it must be there. 7 is also obviously reappearing twice on that diagonal. Once there, once there. I mean, I know I've tried this before. I'm just wondering if I missed something. Once there. Now it has to be, no, not in those. It has to be literally there. Okay, it does look like I can't rule that out. That's incredibly annoying. What I can rule out is 1 ever being on this diagonal, can't I? Yeah, because it's not in those. So, those don't have a 1. Those don't have a 1. These don't have a 1. That's quite interesting. No, maybe what's more interesting is that now 3 or 8 is on this diagonal. And one of these has to be 3 or 8. If it was 3 that had to be there, because it's here, it would then have to be in those cells. And those two. And that one, specifically not on the negative diagonal. Three we're talking about. It would have to be in one of those two, so it would have to go there. Then it would be definitely in one of these two by elimination in column 3. And that would fill up the 1, 4, 3, 9 category. And it would also be up here. I don't know, that looks plausible. That's so annoying. Okay, the alternative is 8. If one of those was 8, one of these has to be 8, then one of these is 8. I've definitely already got one of those as 8. This doesn't work. Right, that can't be 8. Because we've got an 8 X-wing here, so we can't put 8 on that diagonal. Oh, that's relatively simple to see. That's really annoying. So this can't be 4, because 4 can't be on there because it's frozen off by this pair of 4s in rows 8 and 9. And what else? 5 or 7... No, I can't see that either of them is fully frozen out, but we've got this down to 3. 3 is now in one of these cells, along with 5 or 7, interestingly. Because this diagonal is 3, 9, 5 or 7. So one of those two is a 3 as well. And one of these 4 is a 3, so that's now in that row. Am I actually suddenly going to get somewhere in this puzzle? One of these is a 3. Oh, both, by the way, those aren't. They're a 1-8 pair. One of these is a 3, so this 3-6 needs a 3 on that side. It's quite a charming thing to be able to write these in. Right, there's no 3 on that diagonal, so that's not a 3. So this is the 3 around this 2, 3, 5, 6 quad. One of those two is a 3. I know it's not there because of that pair. In fact, that pair and that pair eliminate those two and make this a definite 3. We're getting somewhere now. Slowly, slowly, catchy monkey. 3's not on that diagonal, and it's not in those cells. Oh no, in fact, we've got an X-wing there. It's not in any of those, so it's got to be in one of those. This is effectively 1, 4, 3, 9. Is that giving me any doubles and triples and things? No, it really isn't. Bother. But 3 has been good to me. Didn't get any 3s in the corner. Probably going to get a 3 in at least one of those corners at some point. Interesting. Interesting. Now, let's call the 5 or 7 that appears here pink. That must be in one of these cells. Then it has to be in one of these 3 in column 7. It also couldn't be there. If it was 5, it would have to be here. And it would also have to be here. And it would be definitely here by definition. That would be pink. In fact, this is the original pink digit. That's why it appears here. And it must appear up here as well. So the pink digit has to appear in one of those two cells. Oh no, hang on. It's not X-winged by appearing there and there because it could still be there as a 7. No, it couldn't. It couldn't be there as a 7 because if it's here, it's not in these and it's not on that diagonal. So that is impossible. The pink digit is there or there. It's also in one of those 3, but hang on, it's not on this diagonal. It's what, 5 or 7, so it's not in those cells. Oh, does that mean, it means if it's 5, it's not here? I don't know. I think 5 is the harder digit. If that's a 5, that's the 5 around this quadruple. And you get 5 in one of those, one of those, one of those, one of those. It's very prescribed. 5 doesn't work. If that's a 5, 5's not on this diagonal, so it's not there. So the 5 around this quadruple is there. That pushes 5 into one of those two cells, but 5 as the pink digit is also meant to be in one of those two. So that's not a 5, that's a 7. 7 is the pink digit. This diagonal is made up of 3, 9, 7. Yes. Okay, so 7, the pink digit, is now in one of those two. It's, come on, keep going with 7, the pink digit. It's in one of those two. That's a 7 X-wing. It's got to be there. It's not in either of these cells by quadruple rules. We've got it here and here. Now, I've ruled it out of there because it's not on this diagonal. Yes. Therefore, around this quadruple, it's there. No, it's not. No, it's not. No, it's not. That sees this 7. It's there. That's okay. That's perfectly feasible. This is not pink. 7's in one of those two. Okay. What about 7 in this box? Yeah, one of those two. Okay, I've got 7 pencil marked into every relevant box. And I think 3, not quite. Yeah, I've got 3 pencil marked into every relevant box as well. And 9. Sort of. No, I haven't got 9 pencil marked everywhere. 8, just by elimination. 8's in one of these two. That's a bit weird. Oh, I should think about this diagonal again, shouldn't I? Maybe. Oh, this can't be a 7. Got 1, 2, and 6 there. And 2, 5, and 6 here. Gosh, this shouldn't be taking me this long, should it? I'm just going to get rid of all the pink now, I think. Because, I mean, we've established that it's 7, the pink digit. I don't know what these yellow ones were going to be. There was somewhere 2 couldn't be or something, weren't they? I can't really remember what I was doing earlier. This became a 1, 3, 4, 9 triple. I thought it was going to be useful to establish what the missing digits were, and we got a 7 there. So, in these 2 columns, the numbers given to us were 1, 8, 4, 5, 7, 9, 2, 3, 6. That's one set. 5, 1, 4, 9. We've then found a 3 and a 7. So the remaining digits are 2, 6, and 8 that appear here and as the extra digits around here. So we're only selecting from 1, 2, 6, and 8 around there. Now there could be 2 8s. It doesn't mean that 1, 2, 6, and 8 have to appear here. 2 can't be in that set because 2's in one of those digits. And that therefore doesn't mean that 2 has to be in one of these. Because they could also have a repeat 8. Now, 7, no, I was just going to observe 7 isn't in any of those cells, isn't it? It's not very interesting. Right, that is 2 or 5. So 2 or 5, and that is 1 or 6. So the digits on this diagonal are 9, 1 of 1 or 6, and 1 of 2 or 5. Has that any use in terms of the fact that 4 and 8 are unavailable on that diagonal? I doubt it. But this is tricky. This is still tricky. This really hasn't eased up at all for me. I mean, I know the digits have come in a bit more of a rush latterly, but not much. Let's focus on these involving 2 8s and 1, 2, 6. What does it mean for 8 in particular? I don't really know. I don't really know what it means for 8 in particular. If this was 2 or 6, that digit would not be on this diagonal. If that was 2, this would have to be a 5. If this, yeah, so if this was 2 or 6, that same digit would appear here. That's interesting and quite strange. Is there a problem with it? So if that was 2 or 6, that same. If that was 2, this would be a 5, and then 2 and 5. Now that won't work. Yeah, no, it's not right though. I was going to say 2 and 5 would be the other digits on this diagonal. That's not what this would be proving. Oh, this digit, where does it appear here? Oh, it's so straightforward. It doesn't appear in its own quadruple because it can't repeat in its own quadruple. So that digit on this bit of diagonal appears there. Oh, this is an insight that maybe I could have had ages ago and would have helped dramatically. That has to be a 2 because it's an overlap. Those digits provide an overlap, and it's a 6. Oh my goodness. I'm sorry if that's been staring me in the face. I can't even tell if it has. I cannot tell if that's been staring me in the face for however long amongst the 53 minutes. It could be all of them. I mean, it really does feel weird, but I just couldn't see that. That's a 1, 2. There must be an 8 there. I feel there must be a 6. This is just sort of adding the whole column. Oh, that digit's become a 5. Let's just do it by Sudoku. That's a 1, 3 pair. There's no 1 there. Okay, I was wrong about what digit was necessary or missing. There can't be a 1 there. There is a 5 here. This might fall into place now, but it's taken an awful long time. And Doomed Yacht has not come out of this looking like he's setting easy puzzles all of a sudden. It's probably not what he wanted. That's a 1. That's a 5, that's a 4. Let's get rid of this weird yellow that was never really doing anything. Okay, but we're motoring now. Surely, surely, surely. 6, these diagonals. Come on, 3, 4, 9, 1. There is a 5 there. That's just Sudoku, not the rule. 1, 2, 5, 7. There is a 9 there. And that's interesting. So this is the 5, 7 pair. This is an 8, 9 pair. This is now a 2, 4 pair. This is a 5, 6 pair. 5, 6, 4, 9, 2, 3, 1. This seems to have to be an 8. This is a 2, 7 pair. That has to be a 4. This is a 3, 6 pair. Look, I've got the Fistmafel ring done and everything in it. Don't know why. Where do we go next? Let's go here. That's a 5, 6 pair according to its quadruple. So that's now a 4, 7 pair. 2 has to be on that side. And by Sudoku, 4 needs to be over here. So that's 7, 4. That's 2, 9. Here, 1, 3, 8. We need a 6. And over here a 3, and then the 8 is over this side, so that's 3, 8. This is 6, 9. This is 2, 5. This is 1, 6. I don't know what's going to disambiguate the rest of this puzzle, but something is. That's a 1, 2 on its quadruple. That's now a 3, 8 by Sudoku. This is a 1, 4 pair. This is a 5, 4 pair. Look at all these lovely, lovely pairs. Every digit, every cell in the grid that's not got a whole digit in has got 2 candidates now. And now how do I unpick them? There must be something to do the rest of this. Oh, this feels very strange. Why can't I see what to do next? Oh, it's the odd circle. That's why, because I'm looking at everything else apart from that. That's going to do the whole of the rest of the grid. What a fantastic puzzle. I'm going to be finished in less than the hour now. I am. Maybe not for the video, but for the timer. Yes. 4, 5. Look at that. 5, 7, 3, 7. It was the odd circle. That's so crazy. Oh, I love it. I love it. I'm so excited. I don't know. I mean, there could be people absolutely marmalising my time this time. And well done to them. That's fine. I've really got no problem with you thrashing me on that puzzle. I just couldn't understand the relationships. Took an awful long time. 1, 8, okay, 8, 3. That's 3 in the corner. That's 3 in the spotlight. Losing its religion, like I'm losing my mind today. We've got a 5. There it is. 5, 6, 6, 9, 9, 4. It was that odd circle. It wasn't just disambiguating 2 cells. It was disambiguating the whole of the 2 perimetrical rings of the puzzle. That's brilliant. It's been out there for a year. 700 and something people have solved it. I bet they all enjoyed it. That is so clever. Thank you, Doomdiot. No, your reputation has not been established as someone who sets sometimes fairly straightforward puzzles. Not by me. See you next time on Cracking the Cryptic. Thank you for watching, and bye for now.